Okay, good afternoon and welcome to the second lecture of Python. So the topic for today, a couple of things. We will start to work with lists and we'll start to work with looping using for loops and while loops. And finally some other small additions to the lecture. So first of all, a question for you, a little administrative chore. If you haven't done so yet, please enroll in either group B1 or B2. There's not really a difference there. The only reason that we have two is the fact that Brightspace has a limit on the maximum number of people that can be in one group, and there's more of you than can fit in one group. Because we also use the enrollment of these groups to make lists to register your progress in the assignments. So if you can do this either during the lecture or right after the lecture, that would be great. Second of all, so we're doing things a little bit different now with YouTube streaming. That means that it's also a little bit more difficult for me, at least now, to make quizzes. So if we do have a quiz during the lecture, please use Discord and then specifically the lecture quizzes channel to give your answers to the quiz. So, on to the first topic for today, lists. So if we look at the last lecture, then we learned things about the four basic variable types that we have in Python. Floats, integers, booleans and strings. We can perform operations on them, we can make little calculations, we can modify strings and add strings together. But what if you want to do similar things on a whole range of variables? Well, what you can do is just store every item that you want to do something with in an individual variable, so give each of those items a name. But that can quickly become a little bit tedious if you have like 100 or hundreds of variables that you want to do that for. So it would be much easier if you can store all of those items together in, a list. So that's exactly what lists are for. And they basically look like this. So what you would do in Python to make a list is, a list is also just a variable, so you give it a name. In this case it's LST for list. And after the equal sign you use square brackets to indicate that you are compiling a list. And within those square brackets, each of the items that you want to put in that list, you separate by a comma. And so this list, it's called a list in Python. In different languages it will have different names. It can also be called an array. But in the end it's all mostly the same thing. So there's a couple of things that you can do with a list. If you look at the top picture, then you can see how you can make a list. It's one of many ways in which you can do it, but by far the easiest one. And if you want to get elements out of that list, there's also a couple of ways in which you can do that, but the easiest way to do it is also with square brackets. So you have the name of the variable, which here is still LST, and you add after that square brackets, and then within that square bracket you can either give the index of an individual element within the list. So if you would do LST square bracket 0, square bracket close, you would get the first element in the list. But you can also give a range. And you do that with columns, a start position, an end position, and a step size. And that way you can get multiple elements out of the list in one go. So here you see a couple of examples. If you were to do this, LST0, then you get the first element. If you start using the column, you can get, in this case you get the second until the third element of the list. The last element also has a particular notation. You can use the minus for that. So here you would get the last element of a list. If you would use -2, you get the one but last element in the list, and so on and so forth. So you basically count backwards through the same list if you use a minus. And so as I said, you can use a start, an end and a step. If you don't want to give the start and the end, but still want to indicate the step size, then you can use a notation like this. You basically give everything, but you skip the start position, which would come before the first column, and you skip the end position, which would come in between these two columns, but you only give the step size. So in this case, you get the 0th element, the 2nd, the 4th, and so on until the end of the list. So that's pretty much the basics of how you would use a list. So in principle, by now, you should be able to tell me what is printed if you were to make this list, so a list that contains 4, 1, 6, and 8. And if you were to make these, what is it, 7 or 8 print statements. So that will be the first quiz for today. If you can go to Discord and tell me what is printed here. Okay, I think that looks pretty good. So indeed, if you just print the whole list, which is what we do here in the first statement, then you just get the whole list, 4, 1, 6, and 8. Here we just print the first element, here just the second element. Here we print the last element, so you would get the 8. Here you print from the start, which is the 0th index, until the 3rd element in the list, so that's 4, 1, and 6. Here you print everything up until the 3rd element of the list, so that's basically the same as starting at 0. And what you do here is you skip the first element, or the 0th actually, the 0th element of the list, and after that you just print everything. So in this case that's 1, 6, and 8. So, second quiz. There's a couple of functions here that you may not know yet, but I think they're pretty self-explanatory. So if you can tell me what would be printed here, and I think it makes sense to put everything in one response in Discord, so that they can see everything together. Okay, pretty good. So indeed, I've seen a lot of good answers. With the first statement, we start at the one but last element and we use everything from the list from that point up until the end. So in this case, that's 6 and 8. If you use just a column, you are basically saying, I want everything from the list. So indeed, you then also just get 4, 1, 6, and 8. The len function is used to return the length of any kind of sequence. Well, in this case, it's our list. Our list is also a sequence. So what we do here is that we print the length of the list, which has 4 elements. With max, we get the maximum value out of the list. Well, in this case, that's the 8. With sum, obviously we sum all of the values together, so that amounts to 19 in this case. With min we get the smallest value in the list, which is 1. And of course we can also just enter something other than our list into the max function. We can also just give a range of numbers, and in this case it also picks number 5 as the largest value of the numbers that we presented. So one of the nice things about the list is that you can change it after you've created it. So in this example, we start by creating a list that has 4 elements. So that's the list that we've seen before. But after that, we want to append different things to the list. There's a couple of ways in which we can do that. The first statement is very similar to how you would also append to a string. So what you would do here is just list equals list plus another list that you append to it. But you can also use the append function. So if I were to print list here, then in the end what we see is indeed our first list, 4, 1, 6, 8, appended with 3, 1, 3, 10, and then the 9 and the 8. And that way you can keep on changing your list. So this is all appending, but you can also remove elements from the list. So lists are very versatile. Up until now we've looked at a list that only contains integer numbers, but you can really put anything into a list. So in this case you see that you can also add a string to the list, you can add floats to a list, and it doesn't matter which types you combine together. So it isn't the case that if you start with adding integers to a list, that after that you can only add integers. You can still add anything and combine anything into a list. If you look at the second example here, you can even add lists to a list. So if you look at this list, persons, then it is a list that contains 4 individual lists. And they in turn contain other values, so names with a couple of numbers. So can someone tell me how you would access the second name? So the name that's in the second list within the main list. Indeed. So that's good. So the way that you address nested lists is by consecutively going into the list. So to get the first element, or the second element in this case, of the outer list, because we want this one, the line with Jack. We don't want the first one, that's element 0, but we want the second one, which is element 1. What you would do is do persons 1. If you were to print that, you would just get this entire list. If we then want to get out of this sublist the first element, the name, Jack, then after this statement, persons square brackets 1, we just add square bracket 0, and we would indeed only get the string, which is the name of this person. So to summarize, lists are arrays of one dimension, and you can put basically anything in there. You can also change them after you've created them. You can also make multi-dimensional lists, or at least something that acts like a multi-dimensional list, by putting lists inside of lists. The way that you can then address the individual elements within those nested lists is by using consecutive items of the square brackets. So that's lists. That's a way in which you can store several items together that you want to perform particular actions on. But a loop is a way in which you can actually perform multiple items or perform one or several steps multiple times. And the first type of loop that we'll look at is a for loop. And before we do that, it's useful to have a look at the range function. And what the range function does is it generates a sequence of numbers. And it basically works in the same way that slicing, so addressing multiple elements of a list works. in the sense that it takes a stop, a start and a stop, or a start and a stop and a step. And if you look back at how we could access multiple elements from a list, that works exactly in the same way. So if we were to do range and then stop, what you would get is just a range that starts at 0 and has 8 elements in total. So if you do range 8, and what you would get is a sequence of numbers from 0 to 7. It doesn't include 8, but it includes 8 elements. Because it starts at 0, you will see that it doesn't stop at 8, but it stops at 7. The result of the range function isn't immediately a list. It's a little bit more optimized to make your program run faster. So what actually comes out is an iterator object. That's something that you can immediately forget. The only reason that I'm telling you this is that sometimes you do want a list to come out of that. And if you want that, then what you would do is just this. So you use the range function to generate the sequence that you want. And then you just put list with the round brackets around it. And then the result is actually, again, just the list that you would expect. Well, if you want to also indicate the starting position, then you would do it like this. So this would generate a list that starts at 1 and ends at 7. And if you want to skip numbers, if you want a larger step size, then you can also add the step size here. It should be noted that the range function of Python can only give you integer numbers. We will see in one of the later lectures how you can do this very easily for floating point numbers. So let's look a little bit more at the for loop. If we look at this first example, then indeed you see that we use the range function. And in this case, we just want to do something 10 times. And the way that you write that is as follows. You use the for command, so you start with for. And the statement that you make is you define a certain variable. In this case, it's I. And things that you count are often called I or J or K or something like that, an individual letter. So in this case we want I, and we want values for I in the range of 0 to 10. So what we would write is for I in range 10. The formatting otherwise is the same as the if statement that we learned in the first lecture. So you start with for and you end with the colon to indicate where the for statement ends. After that comes an indented block. And that's also the same as with the conditional statement if or elif. And it basically means that all of the indented code that comes after the for statement is seen as code that needs to be executed as part of the for loop. So in this case, we know that out of range 10 come 10 numbers from 0 to 9. And that in this case, so it means that this statement is executed 10 times. And for each time that it's executed, it gets a different I. So the first time that this is run, it will print 0 times 5 equals, and then it evaluates 0 times 5, which equals 0. So it will print 0 times 5 equals 0. And then it will enter the loop again, but I is incremented with 1. So it will calculate 1 times 5 equals 5, and so on and so forth. Well, as we saw in the previous slides, you can also give different starting positions for the range. You could also give different step sizes. So that's the way in which you can control a for loop. What's also nice about for loops is that you don't have to use the range function. For instance, if you've created a list with strings, or maybe with something that you got out of a file, or maybe values that you calculated previously, and you, for each of those values, for each of those elements in your list, you want to perform one or more steps, one or more calculations. Well, you can use a for loop like that as well, and you can just skip this range function. You can also just say for, well, in this case it's a list of names, so for name in names, and names is a list that we specified earlier. For name in names, we can perform some actions. So in this case what would happen is the for function would loop over the elements of this list, so over these 4 names, and for each of the names it would do print name and it would do print length name. So you would get Anna and then 4, you would get Bernard and then 7, and so on and so forth. So let's make a little example. Because just looping over something and printing how long it is, you can imagine that that's not too useful. But for loops can be useful to, for instance, work with, well, in this case it's a summation sequence. So if we were to make this in idle, well, let's see, I've already started a new file. Let's first have a look at this equation. So it's -1 to the power k. Let's just comment this out, because I just want to know what it looks like, and then I can start making it into code. Times 4 divided by 2k plus 1. 2k plus 1. And we want to do this for k in the range of, well, what did it say? From 0 to 1000. So infinity, of course, would take a little bit too long, but 0 to 1000 is fine. Okay, so that's what we want to do. So there's one variable that we increase from 0 to 1000, that's k. So let's see, so for k in range 1001. And remember, we're doing 1001 because if we would have done 1000, then our loop would have stopped at 999 because it performs 1000 steps. It doesn't count until 1000. Well, next thing, well, let's put in our equation. So -1 to the power k, that basically means that for 0, our sign is positive, and for all odd values our sign is negative. Yeah, no, on second thought, let's just work it out like this. So our equation equals -1 to the power k times 4 divided by, bracket open, 2 times k plus 1. Okay, and then we want to sum that, right? We want everything summed together. That basically means that we need to store some value in between iterations and just add something for each iteration that we perform for k. So let's start. We make a variable that we call result. It obviously starts at 0, and then each step that we make for k, we calculate the current value and we add it to result. So our second step is result equals result plus the outcome of our equation. And that's basically it. We can print our result and then we know what happens with this equation when we perform it from 0 to 1000. So let's see. Python summation.py. Okay, so that's what comes out. You're free to check it for yourself, and if I'm wrong, then you can let me know. So as I said, the range function really only gives you a sequence of integers. But in engineering, you can imagine that many times integer values is not exactly what you want. Many calculations, well, they just have also values after the decimal point. So how would you do that when all you have is Python lists? Well, you could use, for instance, a for loop to populate a list with floating point values. So let's say that I want a list with 100 values that go from 0 in steps of 0.1 to 10, then this is how I would do it. So maybe you can tell me what would come out of this. If I print A, what would come out of that? Yeah, indeed. So if I hadn't known better, I would agree with you. But this is actually what you see. So it's mostly what you say, except for a couple of values. So you indeed get 0.0, 0.1, 0.2. And then you get this weird number, 0.3, but then with a little bit more. Okay. Well, would you get the same if you would do it like this? You can multiply I with 0.1, but you can also divide it by 10. But if you do this, you do get what you would expect. So something that starts with 0.0, 0.1, and all of the values that come after that, they are what you would expect. So what happens here? Well, what you see here is the fact that numbers in a computer, they are stored in a finite portion of memory. So a floating point value in Python is stored using 4 or 8 bytes, so 32 bits, and that has a certain limited precision. Well, the way that this works, you don't have to remember this for the exam, but this is just here to give you a little bit of context. The way that this works is as follows. So you have to store the sign of a number. You have to make sure that your number can become very big, so you use an exponent for this. And then you have the part that determines the rest of the precision of the number. So for the number pi here, it's a rounded down version of pi. What this would look like in memory is as follows. And then you indeed have a 0 for the sign because it's a positive number. You have one part for the exponent and one part for what's called the mantissa. So floats are always an approximation. And because of that, you have to be really careful if you use floats in conditional statements. So if you look at these two if statements, then this won't always be guaranteed to give you the result that you were looking for. So if you say, and x is a floating point here, x equals exactly some number that you are looking for, then that will not always work. And that's because of this limited precision. It could be that your calculations just jump this very tiny bit over the value that you were looking for. What you need to do instead, therefore, is you take a very small range, in this case, for instance, 1 times 10 to the power minus 7. And if you want to see if value A equals value B, then you look at the absolute difference between these two values and you check whether that difference is smaller than this very tiny value that you've chosen. So this is a better way and a more robust way for checking equality with floats than really using the equal sign. And I wanted to give you a little demonstration on this, why the divided by 10 and the times 0.1, why that gives you a different result. This is also something that you don't need to know, but I did think it was useful or interesting to see. And for that I use a library that you'll also not very quickly use. But you can use it to show the exact precision of a variable. So let's say the first value where it went wrong was 0.3. So let's say that A equals 3 times 0.1 and B equals 3 divided by 10. Yeah, so A was indeed almost 0.3, B was exactly 0.3. If we then use the decimal function of A, then we see the full precision of that number, and we see that indeed A is slightly bigger than 0.3. If we look at B, then it's actually slightly smaller than 0.3, but it's so close that the way that Python represents this number is actually exactly 0.3. But even then, it isn't exactly 0.3. And if you look at 0.1, then indeed we see that this is slightly bigger than 0.1, but if we look at 10.0, then that is exactly 10. And so this also gives you a better impression of why, for instance, multiplying by 0.1 gives you a different result than dividing by 10. So maybe end the part about 4 with one final quiz question. And that is, what does this do and what does this print? So have a close look at the for loop, and the print statement is here at the bottom. If you can tell me what this prints. Okay, I see a couple of good answers. So indeed, what this little piece of code does is it finds the index of the minimum and the maximum value in our list. So if we try to break down this list a little bit, then what we do is, we define the list here. And the first thing that we do is we assume that both the minimum value and the maximum value is just the first element in the list. So index 0 for both I-min and I-max. After that, what we do is we loop over the remaining values in our list. So we loop over range that goes from 1 to the length of the list. So we skip the first element because we already stored this index. And for each step in this loop, what we do is we compare the current value of the list, so list square brackets I, to the value in the list of our currently stored minimum value and our currently stored maximum value. And if our current value in the list is smaller than our currently stored minimum value, then we update the index of the minimum value. And we do the same for the maximum. So if our current value is bigger than our currently stored maximum value, then we update the index of the maximum value. And so this is a piece of code that can indeed be used to find the index of the minimum and the maximum value. And the answer indeed is 6 and 4. So the smallest value is at index 6. 1, 2, 3, 4, 5. 6? No, it should be 7, right? Minus 11. Oh yeah, 0, of course. 0, 1, 2, 3, 4, 5. 6, it's minus 11. And then at the fourth index should be our biggest value. 0, 1, 2, 3, 4. Indeed, 57 is the biggest value in the list. So that's it for for loops. So what we've seen is a loop that we can use to iterate a known number of times over a piece of code. And what we can put in is either a range of consecutive numbers or elements from any kind of container, such as a Python list. So that allows us to do something a known number of times. But what if we want to loop over a piece of code, but we don't know in advance how many times we want to do that? Well, that's what the while loop is for. And therefore what you have is, instead of a known sequence, instead of looping over that, you loop while a certain condition is true. And so this is the syntax that you would use. Instead of for, you use the while command. And instead of a sequence, what you have is a condition. And this is exactly the same as the if statement. With if you also have a condition. And what the while does is, while this condition is true, it will execute the indented block of code. And as soon as your condition no longer is true, it will jump out of the indented block of code and continue with the rest of the program. So you could do, for instance, things like this. We make a starting value for something that we want to get from our user. We want to get a value for A. And for so long as that A is smaller than 0, we will ask with the input command from our user. Well, in this case we want to have a number of characters for some reason. So we'll use the input command and we'll convert with int the result to an integer and put it into A. And if the user enters a negative value, then we will print this message. So error, the number cannot be smaller than 0. And as soon as the user prints or enters a value that is bigger than 0, then the while condition is no longer true because A is bigger than 0, and then it will jump out of the loop and go to the remainder of the code. And so in the end it will do this. It will print the finally chosen value of A with a little message connected to it. So there's a couple of different ways in which you can use a while loop. The first thing that you can do is, well, for instance, you can search within a list. So let's say that you have a list A, and within this list you want to find one particular value. It's called AMX here. And here, so yeah, okay, makes sense. So we want to start at index 0, and while we haven't found our value AMX within this list, we increment I with 1 and we go into the loop again. And we just evaluate this condition again. And as soon as we found the value, then this will no longer be true, it will become false, and we stop. And so when this loop is done, we will have a value for I that corresponds to the index within the list of the value that corresponds to AMX. But you have to make sure that this loop ends. For instance, if you were to forget this I equals I plus 1 within your loop, then this while condition would keep on looping and it would never reach the number that you were looking for. But the while loop would just keep on going. And so that basically means that you have made a piece of code that hangs your Python. So a second way in which you can use while loops is by using a logical variable. So for instance, again, you start by setting it to true. What you do then is you do while again, and then within your code you do some logic, getting some inputs. It can be anything that you want to do repetitively. And then within your while loop, at some point you have the opportunity to change this logical statement, the logical value that determines whether the loop should continue or not. So in this case, you ask the user a question, do you want to try again? And if he types something that starts with a Y, so yes, with a capital Y or a small y, then you will go into the loop again. If not, then you go out of the loop. Of course, here in this small example, the difference isn't really big, but you can imagine that if you have a large piece of code within your while loop, then it starts to make more sense to have just this one boolean that has a good and understandable name that controls how often you run your while loop. The third option, also interesting, if this conditional statement is in the end just a boolean that's evaluated, then you can also do something like this. You can just type while true. And then you've essentially created a loop that will run endlessly. It does have its purpose, but you will find out that you really only very rarely run into a situation where this starts to make sense. Almost always there's an alternative that will be neater and less error prone. So I would recommend you to never use this. So for a minute back to the first loop. I don't know if you've looked at it some more, but can you tell me what's wrong about this way of searching a list? Maybe you can tell me in the Discord chat. Yeah, I see a couple of people that give me the correct answer. Indeed, what would happen with this while loop if AMX is not part of list A? Then at some point, your index number I would exceed the length of the list and you would get an error. You cannot access elements beyond the length of a list. That wouldn't make sense. And in that case, indeed, you would get what's called an index error, and your program stops probably earlier than you would have wanted it to. So that's a good example of why you need to be careful of the ending conditions for your while loop, because otherwise you can quickly get into problems of, for instance, having an endless while loop, or getting into issues of overrunning an index of a list, or problems like that. So if we compare the for loop and the while loop, actually what you see is that everything that you do with a for loop, you can also do with a while loop. So if you look at this example, for instance, you want to do something with the number 0 to 10. Well, this is how you would do it in a for loop. You use range, and you use range that goes from 1 until 10, and you make a little print statement. If you wanted to do this with while, it would look like this. You have a number I, it starts at 1, while I is smaller or equals to 10, we perform this same print statement, and then we make sure to increment I. In the end, these two things do exactly the same. So what you see actually is that the for loop is actually just a special case of the while loop. And internally for the computer it is actually also just executed in the same way. But if we can add another example, with the for loops we could loop directly over the elements within a list. What would that look like for a while loop? So let's say that we have a list of values. With for, we can loop directly over the elements of the list. If we wanted to print them all, we would do it like this. That looks pretty neat. If we want to do that with a while loop, it starts to look a little bit more complicated already. Because now all of a sudden we have to keep an index again. Because while it looks at the condition, it doesn't look at the sequence. So here we do need a counter. We need to make sure that we stay below the maximum index of the list, and then we can perform the same print statement. To make things even more complicated for the while statement, what if we also want the index of each element? Well, then these two start to look actually more like each other again, because then for the for loop we can no longer directly loop over list, because we also need the index. So then we want to specify a counter again, counter I, and we loop over the range function that goes until the length of list. So what this does is it gives us the numbers from 0 until the last index in list. And then we can also print, in addition to the value in the list, we can also print its index. In the while statement, well, that stays roughly the same as the previous one, because we already have I, we can just access the element, the ith element of our list. So in different situations, you will either have more benefit from a for loop or from a while loop, and you will probably make different choices here. So back to the endless while loops. You definitely get them when you do while true. And you can also sometimes get them where you don't set your termination condition right. And in those cases, your while loop will run forever, or at least until either an error occurs or when you press Ctrl+C or otherwise terminate your program. Would there also be a different way of getting out of the loop if you don't have access to the terminating condition in the while statement? Well, it turns out you do, and that's what the break command is for. So this is indeed done when you don't want to make use of a terminating condition that you control from within the loop, but instead you would do while true, and then to have control over when the loop ends, you use the break command. And so in this case, well, we also want to get some number from our user, or actually we want to get the sequence of numbers from the user. And as soon as we get a number that equals to -1, if you look at this if condition here, then as soon as the user enters -1, we execute the break command and it steps out of the loop again. So actually what you see here is that we have a terminating condition that's not part of the while statement, but somewhere in the while loop. And what you call that is a sentinel. So -1 is the sentinel of this while loop. But this way of programming, well, it's considered by many people as bad practice, because it can give you untraceable behavior or difficult to trace behavior. Because, yeah, let's say that your while loop is not, well, what is this? 4 lines, but instead it's something like 500 lines. And somewhere within that big block of code, there's one break statement. That quickly becomes quite difficult to trace, because if it stops out of your while loop and you don't expect it, you have to find that back in that big block of code. So by many people this is considered bad practice. And in most of the cases, you can just as easily have an ending condition in your while statement and otherwise do things exactly in the same way. And so if we look at the same example as the previous slide, we just want to check for a equals -1, we can also just put that in the while condition. So this is mostly considered a better practice than using while true. Well, in addition to break, which breaks you out of a loop, there's a second, what's called a flow disruptor, and that's continue. So where break breaks you completely out of a loop, continue just stops the current iteration of a loop and jumps right into the next iteration of a loop. So if you have this while statement, you iterate over a block of code multiple times. If within the code you call break, you go to the rest of the program. If within this block of code somewhere you call continue, you go back to the while statement. With for it's the same. If you do continue, you go back to the for statement. If you do break, you go on to the rest of the program. So that's it for loops. The final main topic for today is formatting output, formatting strings. And that's useful, for instance, if you've already started with the ISA assignment that I gave you earlier this week. Because in some of the questions we ask you to give your results with a certain precision. We want, for instance, the pressure with 2 values after the decimal point. But how do you do that? Because if you make calculations with floats, then you get a much larger precision. You get much more numbers after the decimal point. Well, that's what you can use string formatting for, and there's a couple of different ways in which you can do that. The first one is very close to what I've already shown you last lecture, and that's by making use of string concatenation and the format function. So format is a function that's built into Python, so you don't have to import anything, and you can use it to format some number or another variable using a certain formatting template that you give it. So you enter the value and you enter a template. And this template, well, it looks like this. And there's different things that you can do there for different types of variables. So for a float, you can give, for instance, the precision, which is the first number, and the number of values after the decimal point, and then an F to indicate that you expect a float there. And so if you were to do this, you have x is 1.2. If you print it like this, x with 5.2f, what comes out is 3 leading spaces, because you want something with 5 positions in the string. And then at the end you will get, I think 2 leading spaces. 2 leading spaces. Then you get a 1.20 because you want a 2 decimal precision after the decimal point, whereas your value only has 1. And you want 5 elements of your string in total, and that's why you get the leading spaces. For integers, instead of an F, you use a D, and if you also want the resulting string to be 5 characters long, you will do 5D. Yeah, so that's roughly how the format function works. These are some examples for floats and integers, but you can, for instance, also use it to format strings and different objects. So the second way of doing this, you can also use the format function as a function of a string. And the syntax that you use there is you have your string with the opening quotes and the closing quotes, and then dot format. And the difference here is that you can give the position in the string of where you want your formatted variable to be. And so you can completely give the layout of your string. In this case it's at the end, but let's say that you want your value to be somewhere in the middle of your string. And you can indicate with curly brackets where your formatted variable needs to go. And so in this case it goes at the end of the string. We want to put x in our string, result equals x, and within the curly brackets you indicate in the same way as in the previous example, you indicate how this variable needs to be formatted. And you do that by starting, so curly brackets then starting with the colon, and then after that the formatting of your variable. Then when your string is done, you do dot format, and then the variables that need to go into the string. If it's one variable, it's just format X. If it's a range of variables, then you can add them together, as you see here. You can just give multiple variables, and so long as you have the same number of combinations of the opening and the closing curly bracket, this will work out fine. You can also give variables a name in the format function, and then you can use the same name, so in this case it's a capital N. You can use the same name within your string, within the curly brackets, to indicate where it's supposed to go. If you have a number of variables that go in here, then it could be useful to do it like this. You can also put a list, or a tuple in this case, if you replace these round brackets with square brackets, you have a list. You can expand lists with this star sign, and this way you can also put each of the elements of coordinates into the 3 positions that you've made in your list. The third way of formatting is the cleanest one, I would say, and it's called the F string, and that's really something that's specific to Python. And it basically means that you can use variables immediately in your string. And you do that by, so when you specify your string in between the quotes, you start, before the string, you start by writing an F, and then after that you specify your string within the double quotes or the single quotes, and then everything you do in between the curly brackets, so in between the curly brackets you can directly use the variables that you've declared earlier in your code. So in this case, we can, if we do the open curly bracket, we can directly use X, which is specified here, then the colon, and then specify the formatting that we want to use to put X into our string. So what you can see here is that indeed this gives a very tidy way of including, with a certain precision, including different variables into a string. So those are the main topics for today. For those of you who are already quite far with the assignment and want to tidy things up a little bit, there's a little extra that I want to give you. Don't worry if this goes too fast for you, because we will go into this in much more detail in one of the later lectures. But it can be interesting if you want to make something more out of your assignment. And that's user-defined functions. So if you've looked at your code so far, mostly what you've done is you've just started with lines of code, and your file basically defines where the code starts and where the code stops. And if you use a function, it's a function that's part of Python or part of a module. But you can imagine that if Python can define functions, then probably so can you. And this is the way that you do that. So let's say if we look back at the quadratic equation solver that we made 2 days ago, one part of that is that you have to calculate the discriminant of the quadratic equation. Well, we can make a function out of that. And that's what you do here. So with the def command, you define a function. The name of the function in this case is discriminant, and it takes 3 arguments, a, b, and c. Similar to the if statement and the for and the while statement, the def statement also has to stop with a colon. So that's how Python knows, okay, this is where the definition of my function layout stops. After that comes a block of indented code. It's also the same as loops and if statements. All of the indented code is part of our function. So in this case, we have a function for the discriminant. It takes 3 arguments, and within the function we can use these 3 arguments to calculate some result. So we calculate the d in this case, which is the square of b minus 4 times a times c. And a function can also return values. In this case it only returns d. And so we can use this function that we've made to calculate the discriminant. So define makes functions, you give the function name and between brackets all of the function arguments that you expect. Then you get the code of your function, and in the end you can return nothing for instance, if you want to make a function that only does print statements. But you can also return something, and that can be a list of comma-separated variables that you create with your function. And so functions are really just little programs. So what you've done so far is just make your entire program in one file and then call it. Well, you can also see a function as a little program in itself. You can call that also by itself within the rest of your code, but also in other pieces of code. So that's it for the lecture content of today. From now on you can basically start on the exercises and work further on the assignment. Exercises for today are related, of course, to the lists and the loops. We have an exercise related to calculating factorials. I will put it on Discord right after we stop here. And a prime number test with which you can make a function to test whether a number is a prime number. And if you haven't done so yet, you can finish assignment number 1. If you're done with all of that, then there's a nice website on the internet where you can further hone your skills with Python, and that's Project Euler. And of course you all know Leonhard Euler. He's a famous mathematician, but also a physicist, well, basically anything that relates to science from the 18th century. And well, this guy was really brilliant, and many of the problems that we would currently, so you and I, or at least I, would still find complicated even to do on a computer, Leonhard Euler did those just with pen and paper. And a lot of those problems you will also see on projecteuler.net, I think. And you get the chance to do those with Python. And on Project Euler you can register yourself, and you can also indicate the country that you're from, so that you can keep some statistics for the betterment of your country. But if you look at Project Euler, then you will see that there are already many people that do this for the Netherlands. But for instance, the beautiful Republic of Palau, well, they don't have so many inhabitants, and they could definitely use a little bit of extra help from you to raise their statistics on Project Euler. And for us, that makes it also a little bit easier to trace your statistics on the website. So if you are already done with the assignments, and you are done with the exercises and still want to have some fun, I would really recommend you to go to projecteuler.net and select as your nationality Palau under account. And please sign up with your name and then add either, well, in your case you add -B20, you are Group B and you are from 2020, to indicate your group and year so that we can find you also in the list of statistics and keep track a little bit of how well you are doing on Project Euler. So I can already show this to you a little bit. So I go to projecteuler.net. Well, I'm already logged in. But if you were to go to accounts, well, you have your username. And here you can also enter your location. So just tell them that you are from Palau, that the language you are programming in is Python, and that for some strange reason your time zone is still Amsterdam or wherever you are. Yeah, and after that you can have a look at, let me see, at the list of problems in, yeah, I think in archives, yeah, in archives, and all of these problems you can just have a look at. And the first one is multiples of 3 and 5. If I click on this, I get the problem, and that's something that you can solve using Python. And if you're done, then you can give the solution. So where did we do that? I probably cannot do it anymore for problems I've solved already. Yeah, so this is a problem that I haven't done yet. And then you still get the answer box. So if your code pops up with the correct answer, then you can enter it here. You can check it. And if you're correct, it will get recorded on the website and you can go on to the next question. You don't it's not mandatory to follow this sequence from 1 until the end. You can also just cherry pick the best ones in the list. So that's basically it. Finally, this may be also useful if you want to look at the slides again later, when I put them on Discord. A couple of key functions that are useful to remember when you do the exercises, the assignments, but also, of course, the additional exercises that you can do on Project Euler. And with that, I would say good luck and see you on Discord.